It is well said by J.F. Herbert that there is perhaps nothing which occupies the middle position of mathematics as trigonometry. Hello kids.
Hello ma'am.
I know my statement may have hampered your spirits because you may be thinking that, oh no, another boring lesson of maths. But today we are going to explore a whole new fascinating world of mathematics, you and me. But before that, I would like to ask few questions from you. What is the distance between the earth and the sun? Do you know how this distance was found? What is the distance between the moon and the earth? Without going to moon, how could we found the distance? If I ask you to find the height of a tree in the school compound, how will you find it without climbing on it? Let's try to find the answers to these questions. In all these situations, heights and distances are found by using some mathematical technique. Maths? You must be wondering how maths is involved in these situations. Trigonometry is the branch of mathematics which is answer to all these questions. Trigonometry? What is trigonometry? Do you know the meaning of trigonometry? The word trigonometry is derived from Greek words tri meaning three, gon meaning sides, metron meaning measure. In fact, trigonometry is the relationship between the sides and the angles of a triangle. Trigonometry is one of the important set of disciplines in mathematics which relates to 2 and 3-dimensional objects. Practically anything you can see around you can be related to the principles of trigonometry and algebra. In the real world, it is very useful in engineering and construction, where its principles are used to measure lengths, sizes, areas of objects without actually creating them. Imagine to build a structure with only the land area given to you. You can use the principles of trigonometry without creating the structure to unerring accuracy without a defect. As far as the origin of the subject is concerned, trigonometry and trigonometric functions have a rich and diverse history. Trigonometry is not the work of one man or one nation. In fact, Babylonians and Egyptians had developed theorems on sides of similar triangles long before the trigonometry was taken as a separate branch of mathematics. These two groups had no clear knowledge of usage of trigonometric ratios but were able to use them to their advantage. Egyptians used trigonometric ratios to their benefit in building pyramids and land surveying. Trigonometric tables were created over 2000 years ago for computation in astronomy by Babylonians. The stars were thought to be fixed on a crystal sphere of great size, and that model was perfect for practical purposes. Only the planets moved on the sphere. As the earth is also a sphere, trigonometry is used in geography and in navigation. The ancestral beginning of the trigonometry is thought to be correlated with the shadow lengths and the time of the day. The fact that the shadow of a person is minimum at noon then becomes longer and longer as the afternoon wears on. The shadow tables related a particular hour of a time with a particular length of shadow and were used as early as 1500 BC. What do you use trigonometry for? Historically, it was developed for astronomy and geography. But for centuries, scientists have been using it for other purposes too. Trigonometry is also used in navigation, engineering and construction, physics and chemistry, and many fields of mathematics such as linear algebra, calculus, and statistics. Since these fields are used throughout social and natural sciences, so it's very important to know trigonometry. Trigonometry, however, is not only using formulae to find sizes and angles in the school. It describes the relationship that occurs between the objects and the similarity in their structure. When we compare them using a similar set of ideas, then we are able to understand them beyond just their appearance. Even though we look at a circle, an oval, a square or a rectangle, we can know that we can apply some principles to these shapes through one entity, that is triangle. Before embarking on trigonometry, we have to recap few concepts of geometry also, like Pythagorean triplets, Pythagorean theorem and similar triangles. Let's recall Pythagoras theorem. What was Pythagoras theorem? Pythagoras theorem states that square of hypotenuse in a right triangle is equal to sum of the squares of two sides. So here we are talking about a right triangle. What is a right triangle? A triangle with one of the angles 90 degree. Let's consider a right triangle ABC. The longest side is always called the hypotenuse. This is always opposite to the right angle. The side opposite a chosen angle is called the opposite side. The side next to the chosen angle is called the adjacent side. Let's agree to the standard convention for labeling the parts of a right triangle. Let the right angle be labeled C and the hypotenuse small c. Let A and B denote the other two angles and small a and small b the sides opposite them respectively. The Pythagoras theorem states that the sum of the squares of two sides of the right triangle is equal to the square of the hypotenuse. So we can write it just like this. Hypotenuse square is equal to opposite square plus adjacent square, and in symbolic form we can write it as c square is equal to a square plus b square. Since triangle has three sides, now this theorem can be used to determine one of the sides if other two sides are given to us. Let's see an example. For instance, if two legs are A is equal to 5 and B is equal to 12, then you can determine the hypotenuse C by squaring the lengths of the two legs, that is 25 and 144. Adding the two squares together gives us 169, and the hypotenuse will be square root of 169. The answer will be 13. So this is how we could find the hypotenuse of the triangle. Likewise, if you know the hypotenuse and one of the sides, you can find the other side also. Let's consider one more example. For instance, if the hypotenuse C is equal to 41 and one leg A is equal to 9, then we can find the other leg B as follows. Square the hypotenuse and the first leg. So we know the formula is C square is equal to A square plus B square. This gives us 41 square is equal to 9 square plus x square. Here we are taking b as x because we have to find b. X square becomes 1681 minus 81, that gives us 1600, and finding the square root of 1600 we get the value of b, that is 40. After Pythagorean theorem, let us now recall similar triangles. Do you know what are similar triangles? Let's take two triangles, namely ABC and DEF. Now triangles ABC and DEF are similar if their corresponding angles are equal, that is, if A is equal to D, B is equal to E and C is equal to F. Also, their sides are proportional, that is, the ratio of their sides are equal. In mathematical terms, we can say that AB upon DE is equal to BC upon EF, and that is equal to CA upon FD. Let's consider a situation in which smaller of the two similar triangles is part of the larger triangle. Now, these two triangles are sharing angle A. AEF is part of the triangle ABC here and they share the angle A. When this happens, the opposite sides, namely BC and EF, are parallel lines. This situation frequently occurs in trigonometry where one of the angles is a right angle. All right triangles have the same ratios between their sides, and these ratios have special names which we will be talking about later on. Trigonometry began as the computational part of geometry. In trigonometry, we are measuring angle, and using this measurement we are finding other quantities. Though we are using angle in geometry also, but there we are not using the measurement of the angle. Whereas in trigonometry, we are using the measurement of the angle. So that is the distinction between trigonometry and geometry. With this distinction between geometry and trigonometry, let's take a break. Before we end this session, let's recall what we have learned today. So in this session, we have learnt trigonometry is a branch of mathematics that deals with the relationships between the sides and angles of a triangle. Historically, it was developed for astronomy and geography. Besides other fields of mathematics, trigonometry is used in physics, engineering and chemistry. The Pythagorean theorem and similar triangles, both of these are used over and over in trigonometry. Well kids, after this introductory section, I know that you must be eager to continue this fascinating journey of trigonometry. But now it's time to say goodbye. To keep your knowledge updated, try answering these questions. What is the meaning of trigonometry? How is it useful in our daily lives? What are similar triangles? Observe these figures. Here, triangle ABC is similar to triangle RQP, and few of the sides are given of triangle RPQ, and sides of triangle ABC are given here. On the basis of the similarity, you have to find angle P here. State Pythagoras Theorem. In right triangle ABC, if hypotenuse AB is equal to 25 cm, adjacent side AC is equal to 20 cm, then find out opposite side BC using Pythagoras Theorem. Next time we will study some ratios of sides of right triangle with respect to its acute angle. Till then, goodbye, have a nice day.